Most people misunderstand what science can and cannot do when it comes to training. Scientific studies are exceptional at explaining general biological systems, energy system demands, homeostasis, nutrient delivery, neural adaptations, and more. It provides the map, but you still need to figure out your starting point and ending destination. When we try to make the mechanism jump to this is the best exercise, speed workout, conditioning protocol, or set and rep scheme, we have a problem. Science just doesn't do this poorly. It by definition can't do it. And here's why. Biology isn't a hard science like physics or chemistry. Those deal with stable constants and mathematical formulas. Once you deal with living organisms that adapt, respond, and vary widely in genetic makeup, the precision disappears. You don't get specific protocols, but ranges and principles. Let's look at the two deeper biological truths that make such a precise mathematical approach impossible with performance-based studies. The first is massive individual differences. Any experienced coach has seen athletes who, given the same program, get entirely different results. One athlete makes quick progress, and the other has to fight for every ounce. Genetics plays a huge role in how we adapt to certain stimuli, along with external factors like training history, nutrition, sleep, injury history, and even your personality. Studies report averages. That's useful. It tells you what tends to happen in a group. This can be great for setting starting points and understanding the direction training can go. But averages hide outliers and ranges. We can take a common exercise science study on muscle growth. Do higher training volumes grow more muscle than lower volumes? Often these studies show that higher volumes, within reason, lead to more muscle growth. However, there are inevitably individuals in the lower volume group that grow more than members of the higher volume group. We will look at principles more closely here shortly, but you might be able to derive something like higher volumes typically work better. But what constitutes higher volumes for one individual might be low volume for another. The second problem with precision is structural to the definition of science. Science tries to isolate variables to determine cause and effect, where performance training integrates variables. An athlete isn't exposed to one variable at a time. They're exposed to all of them at once. The very thing that makes research precise is the same thing that limits it for real-world coaching. Let's assume science can give us the exact optimal speed workout. Like if you follow this to a T for the next 10 years, you will get as fast as your genetics allow you to get. What happens though, as we also need to consider strength, conditioning, sports skills, and other unknowns that occur outside the lab? The best speed program breaks down. As we dive into the principles we can derive from science and how to practically implement them, keep this in mind. What separates great coaches from mediocre ones is that mediocre coaches are always looking for the next thing. They want the next exercise or protocol that's going to get all the results. They want someone to tell them what works best. In reality, you have to figure out what works best for that individual. Coaching is about applying principles better to an individual. If not, we would just all get the same results. The research would be clear, and there would be no need for coaching anyway. Sorry, our biology is more complicated than that. We have an entire video practically explaining my 3 principles of developing training programs. Here though, I want to explain conceptually how principles are used to guide training rather than give you an exact answer. So let's break down the actual biological truths behind these principles. One key component of our biology is that our bodies desire homeostasis. This means in order to disrupt that process, we have to give our body a reason to adapt. This is where the fundamental principle of progressive overload comes into play. Our bodies only adapt to a consistent and increasing stimulus in a particular direction. If you want to get stronger, you have to lift heavier weights over time. That isn't optional. Our biology dictates it. Now, what constitutes more and how to best apply that is where some general coaching guidelines, along with studies, can help determine starting points and ranges. We could agree that if I did one hard deadlift workout a year, I wouldn't improve. It would just be a random occurrence, and not a reason the body needs to make structural changes. Or if I did 135 for 3 reps every day, the stimulus is consistent, but not meaningful enough to warrant adaptation. Okay, great, so if you just add stimulus, you'll get better forever. Well, that would be true if biology had no limits, but it does. Our bodies are limited in recovery capacity and its ability to make adaptations. Again, there isn't much of an argument here, but that application is where we get our next principle. If we must continually do more to improve, but we are constrained in our ability to continually do more because of limited resources and time for adaptations, we must rotate the stimulus. This pairs with our body's ability to maintain homeostasis. Adaptations already made will stick around with limited effort, so we have more resources to apply progressive overload to a different stimulus. For example, we go from doing more strength work to more speed training. This lifts the capacity of our entire body, allowing for progressive overload to continue again later. Take this simplified but illustrative example. You build muscle for 8 weeks, then switch to strength work for 8 weeks. You now teach your body to better utilize those bigger muscles and can now lift heavier with them. When you switch back to hypertrophy work, you can now lift heavier weights, progressing that stimulus from the last time you focused on muscle growth. You then build some more muscle and have more mass to do more heavy strength work with, increasing the loads there. The cycle then repeats. While this also doesn't endlessly go on, you can see how this can extend productive training, and where integrating, not isolating variables can lead to an overall higher results. These two principles underlie all training programs. We must balance some form of more with recovery constraints. It really is that simple. The issue comes when trying to practically apply them. This leads to our third principle of programming, which actually isn't a biological one and one science cannot answer. It's driven by our goals. How much time and energy proportionally should we spend on each quality to train? In steps the principle of directionality. Each sport has more important qualities to it, be it strength, speed, conditioning, or skill work. This is where the athlete and coach must work together with practical constraints of the sport and what that individual needs more work on. It doesn't make sense for a soccer player to spend 8 months building muscle to neglect speed work. Now, that athlete might need to build some muscle to improve performance, but that can only be determined through experience and logical reasoning. The exact ratio and time spent on specific training isn't a scientific question. It can't be calculated, it has to be reasoned. Coaching bridges this gap, and it's why the field is described as an art built on top of scientific principles. You still need a strong understanding of how the body adapts, which muscle groups and energy systems matter for your sport, and the general ways in which we train them. Science can tell you roughly what intensities drive certain adaptations, and that's about as far as it goes. Once you move from controlled lab conditions to real athletes with real schedules and real constraints, the practical side takes over. As I progress in making videos for this channel, I will provide more practical guidance, programming templates, and examples to take out much of the guesswork. I understand this video might have limited use in actually building a program. We do have a series on practical programming though, so check it out. The point here is to help you think differently about what coaching entails. It's more than reading research papers and just following what they say. There are practical limitations to science in our field, and while we must not stop trying to learn and discover, we often just need to get better at applying the knowledge we already have, rather than searching for the next squat variation that hits the exact right angle to maximize a specific performance metric. The good news is this makes coaching easier, not harder. You don't have to have everything figured out from the start. You can use reasonable guidelines that coaches and athletes have used for decades and monitor what seems to work best for the individual. This applies not just to the training, but also things like recovery, nutrition, sports skills, and more. There are broad principles to understand and no hard rules that exactly apply to everyone. Make small changes and run your own science experiments within reason on each athlete, developing their optimal program, not the optimal program. If you would like anything covered more specifically, or this raised new questions, please leave me a comment below. I may already have a video on it, and if not, would be happy to make one. Coaching is so interesting to me because while there are similarities, no two athletes or sports are identical. This means we never get to stop learning and improving our skills. We will never have all the answers. If that excites you and doesn't scare you, subscribe to our channel. I think you're gonna like where I go with it.